Hey everyone, we're going to be going through the evidence assignment 7.102. I'll probably also post just a key of whatever we end up with at the end. I probably will not make a video for evidence assignment 01. I might post a key. Remember that one was kind of trickier. So we're just going to be looking at 02 for right now. So we're at Wrigley Field. Home plate is 108 meters from the wall. This is actually the wall in either of the corners. It's 108 meters away. And the wall there is 4.7 meters tall. So here's home plate. And that's a great picture of home plate, right? Here, I'll make it look a little more home platey. Better. And we know that home plate, oh, let's just make a straight line. That's why they have drawing tools, right? You know that home plate is 108 meters from the wall, which is 4.7 meters high. We're going to go ahead and hit a ball, and the question we have is, does it make it over the wall? We know that its initial velocity is 33.5 meters per second at a 45-degree angle. Someone actually did ask a good question. Are we assuming that the ball gets launched from the ground? So I will say for right now, I'm not going to worry about it. I will assume that the ball is launched from the ground, but that's actually something that's kind of an important question. All right, so let's go ahead and make a table for our values so we can sort of plan our route of attack. We got horizontal values, we have vertical values. So I want to rephrase the question, and this is actually a really important tool. A really important thing you need to be able to do is you need to rephrase the question in terms of things that you know how to solve for. So the way I'm going to rephrase the question is this, is when the ball travels horizontally 108 meters, will it be more than 4.7 meters above the ground? Because if it's more than 4.7 meters above the ground, I know that it'll go over the wall. But if it's less than 4.7 meters over the ground, then it won't. So let's go check. So we are going to just start writing things down. I know that it starts off at some place and ends up at some other place that are 108 meters apart. So I'm going to name this spot position 0. So we're going to start off at position 0 meters, and we're going to end up at position 108 meters. I don't know exactly how fast this is going, but I can split it up using trigonometry. 45 degree angle means that it doesn't really matter if it's big sine or cosine, but for the sake of practice, I know this is horizontal, so that's adjacent to the angle. So it's going to be 33.5 meters per second times the cosine of 45. Let's go ahead, let me turn on my calculator. 33.5, 45 cosine times, I get 23.7 meters per second. So this velocity right here, 23.7 meters per second. This will be the horizontal velocity here for the ball. I don't know anything else. We know that there's no acceleration because it's horizontal, right? There's no acceleration horizontally. So I'm not going to worry about that. I do need to know how much time this is going to take. All right, now let's do with vertical stuff. I'm assuming that it starts off at the ground, and I know that that's probably not the best assumption, but we'll talk about that later. I want to know where it ends up. I want to know how high above the ground it's going to be, because if it's more than 4.7, it's a home run, and if it's less than 4.7, it probably isn't. The acceleration, well, we are doing some acceleration now. This will be negative 10 meters per second squared because of gravity. We do know that it does have some initial velocity, and now I could go through and recalculate it. It'll be 33.5 times the sine of 45. But because at 45-degree angle, cosine and sine are the same thing, I'm not going to do the math again. I mean, it wouldn't hurt to do the math again, but you'll get the same answer. 23.7 meters per second. I think that's everything. So plan of attack. We know everything over here on the horizontal side. So let's use all this horizontal information to try to get a time, and then we'll use the time to try to get the vertical information that we need. I think that's probably a good way to do it. So let's go ahead and do our horizontal math here. So the equation we're going to need to use, I don't have an acceleration. I do have a velocity. I do have position. So the only equation that I have that works for that is position is equal to velocity times time plus initial position. So a final position of 108 meters will be equal to 23.7 meters per second times however much time this takes plus 0 meters, which means that my time will be equal to 108 meters over 23.7 meters per second. Let's turn on my calculator. So again, we got to take this 108. Oops, that's not what I wanted. And divide the 108 by the 23. I get 4.56. 4.56. I'm sorry I use a weird calculator. At this point, I'm just so used to it, I don't think about using another one. So maybe I'll switch over so you guys can follow the calculator stuff a little bit closer. That said, if you ever use an RPN, they're nice. You gotta get used to them though. All right, so I think it's going to take me 4.56 seconds. So we want to see after 4.56 seconds, where will this be? Let's find out. So this is our horizontal math. We now know that our time here is 4.56 seconds. So let's go ahead, let's switch our colors again so you can kind of keep track of everything. Our vertical math, we need to solve for y. So I need an equation that has an acceleration, I have a time, I have an initial position, I have an initial velocity. I think I got to use this guy. Y is equal to 1/2 at squared plus the initial velocity times t plus the initial position. I'll go ahead and put a y there just to remind me that these are all vertical values. And let's just plug in things we know. We don't know the position. That's what we're looking for. So that'll be 1/2 times -10 meters per second squared. Okay, I was just about to say my handwriting was getting better, but 4.56 seconds squared plus 23.7 meters per second, 4.56 seconds plus 0 meters. This should tell me how high I am above the wall. So again, let's turn on the calculator. I'll go ahead and do the calculations real fast. So, okay, so we have 1/2 times -10 times 4.56. That -10 shouldn't be squared, that's an error. 4.56 times 4.56. And then plus 23.7 times 4.56. Oops. I added instead of multiplied. And then we add those two things together and I get 4.1. So yeah, this was, let's turn off my calculator so you guys can see that corner. Yeah, so this squared, by the way, should not have been there, my bad. I end up getting 4.1 meters. So that means that when the ball gets there, it's gonna just be short. All right, so I'm gonna say probably no, but let's think about all the assumptions we're making. First off, we made the assumption that we started here on the ground. Maybe we weren't on the ground. Could we have been a few centimeters up? That would bring us closer. We're not that far below the wall. We're only a little bit more than 1/2 meter. So if we could, is it conceivable that the ball was hit that high? Maybe. So I'm going to just start listing things here that could have affected our answer. Unless you know, the ball was hit significantly off the ground, meaning like Vlad Guerrero need not apply. Go Angels. Or I actually asked in the problem about wind. This is really close. I don't know how much acceleration the wind is going to give us, but I actually think wind could probably make up for 30 centimeters. Yeah, over 5 seconds, totally. Wind could definitely be a factor. Now, something that we haven't talked about in our class at all, because it's so close. Something that we haven't talked about in our physics class at all, but if you were someone who actually did this for a living, if you actually looked at this sort of physics, you'd actually have to start thinking about things like the spin on the ball. You might even be close enough that depending on where the ball was when it was actually hit, I mean, did he have the bat swung out? Could that be enough? Long story short, this one's really close. Our initial calculations say no, but it's also close enough for me to go, but I wouldn't be surprised if in real life this would be a yes, depending on certain things. All right, I will go ahead and post this whole image on Classroom as well as this video. So go back, look at your own work, see how well it matches. If you think you got this or something close enough to this, if you think that your work is a good example of this, then count it. Even if you make like a little tiny error or something, right? If you go, oh man, I just put the decimal place in the wrong spot, honestly, I might still count it. So keep track of it for yourself. If you think that you've shown me the evidence that you understand what's going on, record it on your goal sheet. I'll be doing the same. All right, as always, let me know if you need anything. Let me know if you need any help. I'll be in and out of the Discord. Yeah, again, sorry I'm so late. I had such a nasty headache this morning. It took me like an hour to even be able to do anything. Yeah. All right, everyone. We'll call that good. Have yourselves a nice day.